Hello, welcome back to my YouTube channel. In this video, we will be diving into one of the most powerful feature of Polar's library, which is expressions. Expressions in Polars allows us to perform complex data transformations in a concise and highly optimal way. Unlike traditional methods where we might chain multiple operations together, Polar expressions lets us build these transformations in a very single readable line of code. This not only makes our code maintainable, but also takes full advantage of Polar's high performance. In this video, we will be walking through some of the key expression methods available in Polars. We will cover how to perform calculations, data transformations, and aggregations, all within the context of expressions. My goal is that by the end of this tutorial, you will have a solid understanding of how to use expressions to write more efficient and powerful code. So before we jump in, if you are new here, don't forget to subscribe and hit notification bell so you never miss out on the new latest tutorial. And if you find this video helpful, give it a thumbs up. The first question which comes to our mind is why we should use polar expression. The polar expressions combines multiple operations into a single expression, which minimizes the number of intermediate steps, which can result in memory usage, reduction, and a reduction in the computational overhead. This leverages Polar's underlying Rust implementation and multi-threaded execution to deliver high performance. Expressions in Polars are evaluated lazily, which means that the computations are only executed when the final result is needed. This allows Polars to optimize the entire query, potential reordering operations, or eliminating unnecessary calculations, which can significantly improve the performance, especially when we are dealing with a large data set. Concise and readable code Polar expressions create, which helps us to create or write our code in a much more readable format. Instead of chaining multiple commands or methods, we can encapsulate complex logic in a single clear expression, making our data processing pipeline much easier to maintain and understand. The other advantage of using Polar expression is that can be used for a wide range of data manipulation tasks, which we'll see in detail as we move forward in this video. There can be other there can be it supports data manipulation tasks like filtering, aggregation, joins, etc. So we get a consistent API for various operations, simplifying the learning curve and improve productivity. So all right, let's get started. I have got my Jupyter notebook open. You can see it already, and we are ready to explore the power of Polar's expression. So let's dive in. So first we are doing is the precondition of importing polars. So we are importing the polars. We are finding out the version. I'm going to use the same insurance data set which I have been used in this polar series. This data set is from the Kaggle, and I will also provide the video link, or sorry, not the video link, but the data set link in the description of this particular video. So we have created this insurance data frame, insurance underscore DF, and we have read this CSV file. You can see it's a Polar's data frame. These are the columns here of this particular things. So first we are going to start with the aggregate functions. So Polar expressions support aggregate functions. So we can see here, like what I'm doing here is I'm using the expressions aggregate groups function. So here, what we are doing, we are grouping it by gender. Okay, we are maintaining the order in true, and we are using this aggregate method. Now, whenever we are going to apply the expression method, please remember we are using this particular way of writing an expression. pl.call. The call here refers to the column which we are looking forward for it, on which we want to perform the operation, and dot aggregate group. So you can see here, this entire thing is in the one line of code. And we can see here, it has created the aggregation groups here, male and female. And this male female contains all the values because it's been grouped by gender, and we are putting all the groups together. So this is how it can be done. We can also find out the argument max. Okay, we can just say do the keep the same expression pl.call. This is our target column, and argument max. So it's going to give us the index of the maximum value present in this annual premium. Again, the same way we can also get the for the argument minimum, we have to just create the insurance df.select. So it's going to select from the particular data frame. Then the big bracket, which contains the expression. This is the complete expression. And this is going to give us the index of the minimum value present in the annual premium column. We can also go for the count. So it's going to give us the count. You can see here this expression pl dot all dot count. So it's going to give us the count of all the values present inside of all the columns which is present inside the data frame. Next is we can use the implode method. So when I talk about the implode method, what it is going to do, it's going to aggregate the values into a list. So this is our data frame which contains countries and their GDP. Now if I do this pl dot all dot implode, so it's going to keep all the, it's going to move all the countries into a kind of an list. You can see here, and GDP also it has put everything in the list. We can also find out the maximum value. So we can, if I put this insurance dot select and then the expression pl dot call, this is the policy channel sales channel, which is the target on which for which we are going to find out the maximum value. It's going to give us the highest value in the that particular column, which is here is policy sales channel. We can also calculate the mean. We just need to provide the same expression. We have to pl dot call and the target column, and then the mean method. Similar way, we can find out the quantile method. And then this was all about the aggregate functions. Now we will discuss about in detail are the array methods. So sometimes we already know that some of the data which is present inside a data frame or a particular column of a data frame is in the form of an array. So these array methods helps us to do certain operations on these type of array data sets. So now we can see here, this is our data frame which contains the data in the form of an array. You can see here 26, 45, 60, 35, which is in the form of an array. df.select pl.call gdp.arr max. So it's going to give us the maximum value for all. So here 26, 45, it's going to give us 45, 60, 35, it's going to give us 60. Similar way, we can do the sum operation also. The sum operation will add the values present in the array. Then we can also convert them into a kind of a list. So all things, see, if you're looking into this, all the things are here are in the form of an expression. pl.call gdp ar.list. Next is we can reverse the values also. So right now it's in the form of a 2645, 6035. So we can reverse it. And you can see here the reverse value 2645 became 4526, 6035 became 3560. So whatever operations which we are performing in expression, we have to specify the the column name, what kind of operations which we are performing. And see here I have mentioned reverse is equal to, so which means that the result will be stored in reverse. See, you can see the reverse column is being made here. Similar way, we can find it out contains is equal to contains 60. So which is going to give us that 60 is present here in this way. So it's not present. So it's going to give us false. Otherwise, it's going to give us true because 60 is present here. Then we can calculate the argument max, the maximum, the index of the maximum value. And maximum value here is 1 and here it is 0. Then we can also perform a kind of a sorting. So GDP can be sorted out in the this ascending order, because by default it's an ascending order. We can see here 2645, so it's already in ascending order, so it will be displayed as it is. 6035, 3560, because it needs to be converted into an ascending format. Then this is going to give us the unique value. pl.call gdp unique values. How many unique values are there? So this is going to display how many number of unique values. So it's going to give us n underscore unique, so two values. Then we have the categories method. So categories method also, what I'm doing here is I have taken the insurance data frame gender column and I've converted it into a kind of a categorical column, and then dot select, then pl dot call gender categorical dot cat dot get categories. So it's going to give me the how many categorical values are there. So gender has contain male and female. Then we have some column names method. So column names methods are like how you can change the column name by using the alias. So here what I'm done, this is my data frame which I've created. I have done df.select pl.call a alias x. So I'm going to change the name of the column A as x, column B as y. Again, if we want to perform any operations, let's say we have column A and B in the previous in this data frame, and if you want to create a column C, okay, and this column C is basically the addition of column values of column A and column B. So you can see here the column C is being created here in the resulting, and it has values which is the addition of A and B. So 1 plus 4 5, 2 plus 5 7, 3 plus 6 9. Similar way, we can also exclude a particular column. So this is our data frame, and if you want to exclude the column B, So then we can exclude it, and we can also multiplies all column except b by 2. So, and what we are doing, we are performing the operation of multiplying it by 2. So 2 will be multiplied to all the columns a and c, but b will be excluded. So you can see here 2, 4, 6, 14, 16, and 18. Then we will look into computation methods. So computation methods are basically, we can say, a kind of a mathematical operations which we can perform, which can include also some trigonometric functions. So we can see here polars.expression.abs, pl.call. For policy channel, we want to get the actual ABS values. So here we are getting this ABS values. ABS, and then this is our so it's going to give us the absolute value. So absolute values is basically the values which we need, um, which gives us the exact value. If it's a negative value or a negative integer, it's going to ignore that. It's only deals with the uh, with the with the exact values. Next is we can also calculate the cost. So, but please keep in mind that we are creating a kind of an expression here. All the operations are creating it as an expression. Not We are not using any data frame method, or we are not using any series methods. These all are being applied by specifying the column by using pl.call and then that cost methods. Then we can also find the cumulative maximum. Similar way, we can find out the kurtosis. We can find out the logarithm, and we can find out the skewness. We can also find out the unique values present there. So all the unique values will be displayed. Uh, then the value counts, what is the value count of the different values here. Then we have certain manipulation and selection methods. So with the help of the manipulation and selections, we can create we can perform certain data manipulation methods. So here we can see that we want to drop the NAs, null values, from gender. Similar way, we can drop the nulls here by using the drop nulls method. Then we can also sort the filter. So you can see here from the insurance data frame, we are grouping it by gender, and we are aggregating it by creating two columns, LT and GTE. So LT, in the LT we have the expression where it is filtering out only the annual premium values which is less than 2000, and we are adding them. Here also in GTE, this column, we can see that we are selecting the column policy sales channel, and we are filtering the values where the policy sales channel is greater than 500. And then it is being added, and it's being sorted by gender. But this is giving us 0 0 values because it doesn't satisfy there's no values matching this condition. So that's why the values are 0 0. Then is the pipe method. So pipe method, we know, we have already seen in the data frame and the series method. Similar way, the pipe method is like if you want to do 2 3 operations together, so you can put that in the expressions format. So you see here, I have two methods here. This is my data frame. I'm add and multiply. What I'm doing here is doing the expression with +2 and multiplying it. Now, what I'm doing here is I'm selecting the column. I'm selecting the column A, then I'm doing the pipe, and then I'm using this particular method, add 2 and multiply. Multiplier is equal to 3, uh, and alias, this is A transform. So then it's going to give us the values. So I would request everyone to just also practice it on and see the output and analyze the output yourself. Then this will gives you much more concrete idea. Next is the slice method. So we can slice the values also with the help of the expressions. So pl.all. So for all the values and slice 1 and 2, which means that I'm going to slice the value of with index 1 and with index 1 and 2 values. So one more value will be after one more value will be displayed. Two values will be displayed. We can also do the sorting using this expression method. Um, then we can also do by sort by, if you want to sort by a particular column. So we can do that also. That I want this policy sales channel to be I want to select this policy sales channel which is being sorted by the annual premium values. So that way also we can do. We can also provide the limit, and here we have done the reshape also. So this is our ranking. This is our data set, data frame, and we want to reshape into a kind of a 3 3. So you can see here it's being arranged in this format. format. Next is the name method. So name method here is the lower method, which what will happen is like it's going to change the name of the convert the column name into a lower column name. So timestamp will become smaller timestamp. Then we have the keep method. So if we are, let's say if we want to create a kind of a new column, which this new column is a result of a certain operations on a particular existing column, but we want to keep the name of that particular new column as a same as the previous column. So in that case, what we can do, we can just use the method keep. So you can see here we are performing the operations of multiplying the annual premium by 9, but we want to create we have changed the name also here, but later on we just mention it as keep. So what will happen, the new resulting column will have the same name as annual premium, you can see here, but the resulting result here is the final value, but which is being multiplied by the actual previous annual premium column values. Next is the operators method. So in the case of the operator methods, what it does, we can do the filtering also. We can perform the greater than 2, and we can perform the bitwise operations of and. So it's going to find it out like with the condition if ranking is greater than 2 and GTP is less than 54. So it's going to display only those values. We can also perform the OR operation with the two different conditions. PL.call ranking is greater than 2 and PL.call GDP is less than 54. Next is GE. GE is basically greater than and equal to. So any values, it will display only all the values where we have the values greater than equal to 3. Next is greater than 3. So it will only display values which is greater than 3. This is greater than 4. So greater than 4 is going to display all the values which is greater than 4. Then which is less than 4. Then we have NE. Not NE is here refers to not equal to 2. So all the values which is not equal to 2 will be displayed. So we can see here all kind of comparison operators and operators like or and we can perform in this kind of in this type of methods. We can also do the add method. So we can see here we are adding the ranking and the GDP, and this is the total new column. So total will be this way we can add it. So basically it's all the mathematical functions in this operators method. Next is we can also perform the floor division. Uh, then other thing is this was all about the operators. Now we will discuss about the Windows function. So polar Windows functions are similar to the SQL functions. Windows functions allows us to perform calculations across a set of table rows that are related to the current rows. So these are particularly useful for tasks like running totals, finding out a moving average, or calculating ranks within a particular within the partition of data. So we will look into the over method, expression.over method. So this is our data frame which contains department. This is our sales. So what we are doing here is we are targeting the sales column, and we want to find out the cumulative sales. So we will apply this cumulative sales over department, over all the departments. So Arial. So what we are doing, and so this is how we did it. So Arial, and this is the sales. Okay, and then this is the cumulative sales. So 200. Then 200 plus 150 is equal to 350. Cumulative means adding the previous values. 350 plus 300 is going to give us 650. 650 plus 400 is going to give us the. But we have here specified only 3 values. So that's why this is how the cumulative sales is going to work. Now for biscuits, you can see 400 plus 254, 650, 650 plus 500, 11,050. So that's why it's going to doing is calculating the cumulative values by using the over method, by iterating through all the rows of the Arial and biscuits respectively. Similar way, we have the rolling function. So when we talk about the rolling method calculates the rolling statistics such as moving average, sums, or counts within a specific window size. So when I say rolling sum, window size is equal to 3, and rolling means. So what it will do, it will go through 3 dates. Okay, so you can see here for first one, it's going to give us null because We have specified 3. So there's no value before it, and there's no value before, two values before this one. But if you look at this 200, okay, so what it will do, it is going to calculate the values of this present 200, okay, plus the previous two values of the date, because it's window size 3. So 200 plus 150 plus 100, so it's going to give us 450. Okay, similar way for this one, it's going to calculate for this value 250 plus 200 plus 150, so it's going to give us 600. For this value, it's going to calculate 300 plus 250 plus 200. Okay, because we have specified 3 time lags. Okay, so this is how 300 plus 250 plus 200 is going to give us 750. Similar way, we can calculate the rolling mean also. This was rolling sum, so rolling mean will be also done by 3 time period. So this way we can calculate it. Next is the temporal functions. So temporal functions are basically referring to the data frame which contains time attributes. So we can see here, this is the data frame which contains the column called as timestamp, and it has the value in the form of a date as well as in the form of a time. So it's a date time stamp. So if you want to calculate if you want to find out the date only, so we can just calculate the date by using this dd.date function, and you can see everything is uh, inside the expression. So date, it's going to extract the date from here. If you want to calculate the day, you can see here the day is being extracted here. Hour, so hour will be extracted here. From the timestamp, you can see here 12 is the hour. Okay, if you want to find out the minute is being extracted here. You can see here 22, 34, and 19. Month will be also extracted here because all belong to the month of August, 8, 8, 8. And then we can also extract the time, the whole time, this whole time series part. So this was all about the temporal functions. There are other functions for list, string, and list expressions, which can be practiced on your own. So this was all about the polars expression. Let me know if you have any questions in the comment section, and if you want any other kind of tutorial, please mention it in the comment section. I will make a video out of it. Thanks everyone for watching. Stay tuned for more videos. Thanks a lot.